you. And then Peter, I'll hop over to you and ask specifically for you to tell us a little bit about the Wildfire Initiative, how you assess sort of the supply chain's access to capital maybe right now within urban air mobility, and then maybe if you see any potential breakthroughs technologically on the horizon. And then I'll end it with a couple of questions for Dana if we still have time.
Okay,
and
super.
Obviously, everybody can hop in as they need be.
And Steve, just in case, if I didn't answer a question in like couple of seconds, then Dana or Peter can answer that. You know, in case I get pulled into this other thing at ICAO, they are also somewhat agile, so I might get pulled in unexpectedly. But we, you know, given that now Peter and Dana both are there, there's a little bit backup. I think they have heard me talk many times, so I'm sure they can reflect some of the thoughts, and I'll join in. What I got going on is one year, one computer, and another year, another computer, and 2 Zooms. So I'll try to. That other panel has like 9 people, so my turn is unlikely to come, but you never know. I just finished my talk there, you know, so that's all done. Now it's the Q&A. And
Okay, it's 3:05 on my clock. Josh, are we ready to go? Josh? So I'm chatting to Josh to see if we're ready.
Yeah, I can see he was having some kind of audio problems, it looked like a few minutes ago.
Yeah, and I still can't start the video.
Yeah.
yeah, me neither.
While we try and figure that out, it looks like we do have participants finding their way in. So I'm going to go ahead and assume that we're cleared hot to get started. So I appreciate everybody's time for getting together today to talk about the urban air mobility supply chain. My name is Stephen Pinky. I work in the Air Force's Office of Commercial and Economic Analysis, and I'm going to try to do my best to moderate today's discussion. So I appreciate everybody's time, and you know, we don't have a ton of time for this one, so I'll ask for folks to introduce themselves, and then I'll dig into some questions. So PK, if you want to start by introducing yourself, that'd be great.
Sure. Thank you, Steve. That's a great opportunity to be here. My name is Parimal Kopadekar, or PK, and I am director of NASA Aeronautics Research Institute. We do unexplored area and the trends related to the areas that we should imbibe in aeronautics. Thank you. One of the
Great.
areas we are focused on is supply chain. So that's why I'm here. Thank you.
Peter?
I'm Peter Shannon. I'm the founder of Radius Capital, which is an early stage investment firm really focused on the enabling technologies and the supply chain and the software and systems that are driving advanced air mobility. I've been in the venture business for about 15 years, focused originally across all technologies, then down into sustainability-oriented technologies, then into mobility, and now into this space. And we are, we're really taking a very specific lens from a domain area standpoint, but investing across a broad swath of technologies, really technologies that sit on the very frontier of what we're doing across data, communications, software, propulsion, energy, and other areas.
Okay, great. Awesome. And Dana, you want to take a second to introduce yourself? And it looks like our video is finally working.
Yes, we finally appeared. So my name's Dana Jensen. I'm also with the Office of Commercial and Economic Analysis within the Air Force. I've been spending a lot of my time looking at the eVTOL supply chain. PK and I co-lead, along with FAA, an advanced air mobility supply chain working group that already has a couple hundred members and counting. It's been great to be able to interact with the members and aspiring members of the supply chain out there. So I'm really looking forward to the discussion. Without further ado, I'll just get out of the way.
Thanks, Dana. So along those lines, I'll start with you, PK. Based on what Dana just talked about, right? You guys are leading a multifaceted urban air mobility supply chain working group. Can you tell us a little bit about who's participating, why you stood up that effort, and sort of the industry's reception to those efforts? And I'll let Dana sort of pile on after you give us a background there.
Yeah, no, thank you. That's a great question. So we started the supply chain work group because we felt that there was a real need to bring the current suppliers and would-be suppliers and connect them with the OEMs, original equipment manufacturers in the eVTOL and emerging aeronautics industry at large. We have seen many, many challenges of sole source suppliers, single source suppliers, shortage of materials, long lead times. So we want to try to change that dynamics. What we learned from small drone industries that we didn't have enough resilient supply chain. So we want to try to now be very proactive rather than be reactive for establishing the supply chain. So we started the working group. We have a great reception. Over 400 people are already, organizations are signed up. And what's so good about it is a lot of non-aero companies are joining and want to be part of that. So we are actually building an ecosystem and generating momentum and creating opportunities for companies that didn't have those opportunities before. So that's really the exciting part that Dana and I are focused on, in addition to FAA and Department of Commerce. And we have a multi-agency government kind of cooperation to support and reduce the friction. So first thing we're doing is electronic exchange platform that allows the suppliers to connect with each other as well as the OEMs. So that reduces the friction for OEMs to find the suppliers. Then we will be doing modeling and simulation to understand the future needs and then figure out where the gaps are. Do we have enough ball bearing makers? Do we have enough magnet manufacturers? Do we have enough propulsion system, motors and batteries and all kinds of things? So really to make sure that we have readiness of supply chain as the move starts to happen from pre-certification to certificated aircraft and over a period of time, the scalability. So right now it's the access to suppliers important. Later on is the resiliency, having redundancies, and then over a period of time is the scalability. And then as the operations begin in the maintenance, repair, and overall supply chain, that's another critical component. So we're really excited, Dana and I and our FAA and Department of Commerce counterparts are really helping, trying to push the ecosystem to make sure that the lead time to find suppliers is reduced and the cycle time between iterations is shorter.
That's great, and I'll let Dana pile on, but sort of specifically to you, Dana, one of the things PK brought up was suppliers that weren't necessarily even looking at this market, that you guys are sort of pulling into the ecosystem. Can you talk a little bit about that dynamic, and then the support and the effort that you're bringing into the supply chain working group?
Yeah, I mean, in some cases, I mean, we've seen, of course, that there have been big strategic investments by the automotive manufacturers in the eVTOL space, and the thinking is that they can provide that scalability and manufacturing capability that would get these firms into big commercial production. The thing about that is that I think that argument still holds, but we need to remember that automotive is really the main driver of the development of things like electric motors and batteries, but they optimized for price, not for weight, right? And so to some degree, it's not an easy thing to shoehorn some of their technology into places where you think it would make sense because they have corporate relationships and the ability to scale. So as it turns out, a lot of the relationships we're building and the potential suppliers we're identifying, some of whom, as you mentioned, aren't aware of UAM at all or weren't, involves taking firms that are smaller but looking specifically at the space, right? So they're not mom and pop startups. They've got a line of business going already, but they also make motors that are kind of more specific to eVTOL. So a lot of it's going to involve kind of engaging these mid-size or relatively small-size firms, because the huge ones really, they don't want to shut down production lines to try out some new prototype part, right? That's prohibitively expensive. And so I think we're starting to realize that we're relying really more on the smaller end of the spectrum. Now, what that means, of course, is there are a lot more of them, and there's a lot more due diligence to be done, right? So it's a contact sport out there trying to figure out, who these guys are. And to PK's point about supply chain more broadly, of course, we want to understand it and promote it and protect it. We also want it to be resilient, right? And what we've seen through the pandemic is that resiliency is a much bigger deal than we thought. It's not all about efficiency and cost. And so, the phrase we've been using is, moving from just in time to just in case, right? That it's okay to be distributed even if that's a little more costly, right? Because it could save you in the long run. When you concentrate things in one geographic area, you're asking for something bad to happen, if that area is tectonically active or politically active or whatever. So we're starting to think broadly about these things, but also about bringing in these kind of smaller suppliers who you wouldn't traditionally think would be big players.
Yeah, that's great. And back to you, PK, you touched on it a little bit in your answer to the first question, but can you talk to me a little bit about sort of that methodology you're using to gain the understanding of the supply chain, and then maybe a little bit more about the sort of that system interface that you're talking about, where it is in the development? Is that something that folks are already using to connect across the ecosystem? Just if you could dig into that.
Yeah, that's a great question. We just started that, and we built the first is RFI. We want to be very inclusive, so we put a request for information. We got 400 some responses, and it's growing. We have a work group every month. We meet and discuss topic by topic, and then address those issues related to supply chain. And our goal is to first build a electronic exchange platform to connect these to reduce the friction, and then move to modeling environment. So all the way to the lower tier. One of the things that we really discovered is the understanding of the lower tier performance and access to the lower tier suppliers. So not just looking at the top tier, but what happens at the lower tier has a lot of deeper implications. And that's why we are building this model network, digital twin, so to speak, digital engineering model of the entire supply chain, and then analyze it. So right now we are at a stage where we are building a database oriented electronic exchange platform. That's where we are. And through work group, we discuss many opportunities, many challenges the current suppliers have, and connect OEMs and suppliers and understand the best practices where the gaps are and such.
No, that's extremely helpful. So as you guys, both you and Dana, are engaging the ecosystem right now, and I apologize, Peter, I definitely am going to get to you with some specific questions, but what are some of the bottlenecks that you guys are running into or seeing emerge already in the conversations that you're having across the ecosystem?
Electric motors. I mean, everybody starts with batteries, and it's true. there are a lot of smart people working on batteries, and there are a lot of resources being thrown at batteries, again, mostly toward automotive, but also toward aerospace. So I'm confident that we'll make incremental progress there. Electric motors right now, ARPA-E thinks that if we're going to electrify, a single aisle aircraft, like a 737 or an A319, that electric motors are going to have specific powers on the order of 12 kilowatts per kilogram. Right now, the state of the art, which actually may not be US, is in more of the 4 to 5 kilowatt per kilogram range. So there's a lot of very interesting work being done on 3D printing of stator windings and Halbach arrays for magnets and other enablers that I think, if they're integrated properly, could get us close to that 12 or 13 kilowatt hour per kilogram goal. But for the meantime, one of the most frequent questions we get asked is, who's a supplier of motors that aren't going to overheat? Who can do? And again, it's not just the motors, and it's not just the batteries. It's what connects them too. These aren't wireless systems, right? You're putting 800 volts and a huge amount of current through a lot of these wires and rectifiers and inverters and switches. And so, where are the power electronics optimized for this stuff? So propulsion doesn't live and die by batteries. It's also how they get connected to the motors and the capacity of those motors to run at the right levels and not overheat. So if I had to name the kind of the number 2 issue that we're seeing and being asked about, it's electric motor sourcing.
Peter, I saw you starting to chime in. Do you have something to add?
Oh, no, go ahead, please.
Okay. PK, is there anything beyond that you wanted to bring up?
Oh, I also want to say that we need to support the would-be suppliers, the ones that are entering into aviation. They have a different perspective from their previous background on the insurability and underwritership. So that is different. So I think we need to help with them.
Okay. Yeah, great input. So Peter, now finally getting over to you. I know that you're doing some cool things looking at the supply chain within the marketplace. Can you tell us a little bit about your wildfire initiative, what that is, and sort of a little of the background for us to better understand?
Yeah, certainly. And to frame it with some context relevant to the discussion that we're having here, when we consider the set of challenges that faces the supply chain, obviously we look at further down the road, the scaling up challenges for supporting all of the vehicles and the applications in advanced air mobility space. We look at the technology gaps that exist today, and where does the early work need to be done in terms of R&D to stay ahead of those gaps. Another angle on the challenges that the supply chain faces is, how do we create a nimble supply chain that is able to respond to the needs of startups that are in a development phase, where they are still at low volume, where they need a great deal of responsiveness and flexibility in terms of prototyping small volumes of divergent new types of products or solutions, and being part of that iterative solution development process as this technology is developed for a given application. And part of that is looking at where are the early applications emerging that are going to be the test bed or the basis where these technologies get into the air and where they mature and where they begin that scaling process. And one of the interesting areas that we've identified in this last year has been the application of new technologies towards the entire spectrum of undertakings around managing and mitigating wildfire risk. So it's everything from using these types of assets for measuring risk and doing things ahead of fire season to prevent fires, to detecting fires when they are actually, you're in a high risk time in certain areas and certain weather. And then to using these types of air assets to completely rethink the response to fires and the suppression, delivering water or fire retardant onto an incipient fire in very short order, and tightening those types of control loops. And so we have created a proposal to put together a program that leverages some of the templates and some of the best practices that AFWERX have developed. We are partnered with NASA on this. We're partnered with a number of other aerospace companies and startups. And we've put together a proposal starting with the state of California to the governor's office to create an organization that will establish these types of simple pathways for connecting the startup and innovation community with the operators, with the domain experts in forest management and in wildfires, to create, to begin a collaborative process to scan and identify potential technologies, and really taking a very open-ended view to looking at revisiting the basic assumptions and looking at radically different solutions to what we do today, and then creating an overall plan and a roadmap for integrating some of the near-term technologies that can be put to use by next fire season, as well as creating an integration pathway for the further development or adaptation of technologies that, with operational testing and with some refinement, and of course support from the supply chain in doing this, can become new tools in the spectrum of how we manage and mitigate wildfire risk. So the reception from the state of California has been great so far, and we're deeply engaged with them. And NASA and us are working on a workshop for early next year. I expect it will be in late January or early February. And we're going to be convening a group of public officials, researchers, and innovators in the space to frame this program going forward and to bring people up to speed and get the collaboration going. Because there's, this is tremendously important. It's in the national interest, and it's an area where technology has difficulty organically finding its way into this application space. It is an area where we need to create purposeful facilities to enable it, not unlike what we see in the defense community, where those facilities are very matured. And we're going to do that here in the wildfire space, and we expect to see some really, really interesting changes and some really creative foundational technologies that are matured and scaled up in the process. So it's very exciting.
Yeah, no, that's phenomenal. I think, every time that we re-engage with the community, I feel like there's another use case for these systems that keeps popping up as people keep putting more and more brain bites into the capabilities and seeing them, right? Like when you see one of these up close and personal and see what it can do, you start to get all kinds of ideas that percolate of what these vehicles are capable of accomplishing. So, I mean, I think it's amazing, right? Digging into just another use case and trying to bolster the overall marketplace by bringing something earlier to the marketplace and really driving that forward. But along those same lines, you said obviously as you pull things forward, right, supply chain becomes much more of a challenge. Do you see there to be capital gaps sort of in that supply chain market right now that I guess you specifically, or maybe some of the other capital providers are starting to fill in, or areas that just you're going to need to mature as those use cases bring the early revenue streams that may drive more capital to flow into the market? I think at the OEM level, right, Dana talked about the auto manufacturers are definitely bringing significant capital, but down at the supply level, it's a bit of a distinction of how that money flows. So if you could talk to that a little bit, that would be great.
Yeah, I think that we do see some capital gaps, and I think that this process is really going to help us identify those more specifically and uncover yet more of the capital gaps. But when we think about where are the capital gaps, what is the origination, right? What is the cause of the capital gap? In some cases across the air mobility space, it is a question of timing, and it is a question of what are the use cases going to be in the near term, and how can we de-risk that, and how can we pick our product or technology strategy as a supplier to take the path that is the least subject to the vagaries of the timing or the form of the things that fly. and the way that their technology manifests downstream in the supply chain. And by developing this pathway for innovative solutions in the wildfire space, we think we're going to de-risk that question, because we are going to establish with a greater degree of certainty a new pathway for this technology to get into the air and to begin maturing and begin making a real difference. And I think that doing that is really a question of providing clarity to the private sector in terms of what is needed for this new type of application space, and what is the support from the public sector or from the regulatory sector in order to allow this to move forward. And the wildfire space has the potential to be a really accommodating, really compatible application space and community of people where we can go and get into the air and get those things tested, matured, operationally integrated, and making a difference. And so that is going to, I think, really assist with this question and bring some more clarity to the supply chain and to the capital allocation decisions that the people managing that supply chain are going to be making. So we expect that this is going to really elucidate a lot of clarity on all of those questions.
Yeah, and I think I'll jump over to Dana real quick. I think, we've seen a couple other use cases in our discussions, right, that specifically align with some of the things that you're bringing up here, in the sort of the medical field and emergency care, EMS stuff, which is very similar in the acceptance side of the house, as well as probably, having some dynamics to allow it to overcome some of the hurdles to get things out on the street, because you're talking about lives at risk along the same lines as wildfire. So, Dana, can you talk a little bit about that use case that we've sort of seen mature over the last 12 months? You're muted, brother.
Sorry about that. There are really two iterations of it. One is full-on medevac, right? That you've got a vehicle large enough to accommodate and designed to accommodate a gurney and a flight nurse and a pilot, akin to what we would think of as a helicopter, life flight kind of helicopter. That's the maybe a little further down the road use case. The one that's more compelling immediately is based upon some work that MIT did talking about the fatality rates from cardiac arrest. And that really cardiac arrest is all about getting an EMT, a first responder, to the scene as quickly as possible. They don't really need much equipment beyond an AED and some drugs and some monitors. And so it can be a one passenger, lightweight vehicle, ultralight vehicle, so it doesn't need to be type certified. They're cheap enough that you can perch one on top of every fire station, and the guys can learn how to fly them relatively easily. And their projection was that, if you can save even a couple of minutes in response time because your ambulance isn't stuck in traffic, that you're going to save tens of thousands of lives a year doing that, right? So the vehicles are cheap, they're easy to fly, they're available now, and the public acceptance shouldn't be a problem. They're not loud, and they're cheap enough that you can give them, to every fire station around pretty much, and they can fly off the roof. So that's a case where it's foreseeable that we could have those things flying. And again, local governments are going to be making a lot of these decisions, right? So you're going to see them maybe adopted as kind of a patchwork around the country based on local budgets and willingness to accept them. But I think that's a pretty frictionless initial use case. And there are a couple of startup firms that are working on that case, and there are a couple of vehicles now that pretty much fit that bill. So I think that's going to be the initial one. The bigger, sort of more medevac oriented case, and this would be the one that DOD, of course, I don't think cardiac arrest is really a major cause of fatalities in combat zones. So DOD really is more interested in that sort of traditional medevac sort of thing. And so, again, that's a bigger vehicle, more powerful, presumably louder. And, there are a couple that could potentially be modified to do that, but I think it's a little tougher challenge to get vehicles that'll meet those criteria. And the one thing I will also point out, if you think you're going to have an eVTOL vehicle that flies out and responds to traffic accidents, I would caution that most traffic accidents happen in bad weather and at night. And so to the extent that these initial vehicles are not going to be able to handle either of those things, it's going to be, you know, longer until we actually see them responding to things that aren't, you know, VFR condition kinds of things. And just by definition, a lot of accidents happen in bad weather. So I'm a little more skeptical of the vehicle accident response use case initially, except in kind of special conditions.
No, I think that's extremely you know, important additional use case, right? That we need to keep track of and understand, especially, you know, when you're talking about a sort of a patchwork across the nation of how those may emerge in that use case. I think it's definitely something as the service and our interest in that marketplace we need to keep track of. Let me hop over to a question that came into the chat, and I think for PK to start, but maybe you know, Peter and Dana can jump in as well. But can we talk a little bit specifically about the visibility and traceability that exists in the supply chain? Obviously, right, the government's got a lot of focus out there at present on understanding the details of each level of supply chain. And the question is, how much visibility into that do we have, and how important is that to the process that you're putting together? So if PK, if you want to hop on that, and if
Yeah,
not,
I'll just quickly start and then I can continue. It's really important to have the visibility all the way to the lowest possible tier, which is the materials. If we want, not just look at the tier one, because here is an example: Fukushima disaster happened, and then all of a sudden we had issues with the ink that went into PCBs and PCWs, and that ended up having problem that was lower tier. And that is kind of things that we can afford to miss. Pharmaceutical industries learned that some of the parts, materials come from one country, and that's a big bottleneck. We want to make sure that that does not happen in aviation. We have a resiliency in the whole network. Cobalt is another example. Cobalt is actually one country, and many high temperature, you know, components use it. We can't afford to say that, oh, we ran out of cobalt, or all of a sudden we don't have enough access that we want. So we need to be able to understand that and then do the trades and analysis. That's the real power of this modeling simulation, to be able to understand and look into future and future-proof it.
you have anything to add, Dana?
Well, I will say there are some additional data points that might help us with this. The Department of Commerce has an MOU with Customs and Border Protection to get access to their automated commercial environment. It's called ACE. And that's got all of the Form 7501 submissions of all goods that move in or out of the United States, who sent them in, who's sending them out, who's receiving them. And it's a very granular view. It's based on the harmonized tariff schedule. So it's got a very granular scheme for categorizing the goods that are moving. It's also a scheme that can be readily adjusted through a mechanism that's well known. So for example, we were to start working with that data set, you know, and we saw that we didn't care if a widget was blue, but we did if it was red. Otherwise, they look the same. We could have them, ask them to bifurcate that into those two categories. So it's a very nimble system as well. And Commerce is now exploring the data with a couple of data scientists to see what they can suss out. They've had a couple of early wins tracing the raw materials for the production of PPE, making sure that the stuff wasn't getting exported at a time when we didn't need it exported. So that's a potentially very useful system. The other thing I will say is, I mean, and again, we talk about raw materials, you know, the poster child for this is neodymium, right, for permanent magnets and motors. You know, Toyota Prius has a 60 kilowatt assist motor and has about 1 kilo of neodymium in it. If you were to use that ratio and apply it to some of these larger eVTOL vehicles, you know, you're talking about maybe 5 kilos of neodymium per vehicle. Now, that material, neodymium metal, trades at $50 or $60 a kilo. So even at the scales we're talking about with aviation, it's a drop in the bucket from a cost standpoint, right? I mean, when you're building an aircraft, you know, $450 extra in neodymium, no big deal. It's a matter of access, right? So it's not all about the cost. I mean, if access were limited, cost would go up, sure, but I mean, can you get it at all? And so that's more of a geopolitical, issue. And I think it's something we've all wrestled with. And there's an executive order that discusses what are we going to do about this. But again, I'll fall back. I think a lot of people say, well, rare earths are rare and they're expensive. No, they're not necessarily, right? I mean, it's just hard to get them. And so I'll leave it at that. I mean, that's the raw material question du jour, but I'm sure there are a bunch of other ones. And if we start looking at this ACE database, I'm sure we'll uncover others.
I appreciate that, Dana. There's only a couple minutes left, but just one question, that I'm going to hand back over to Peter. When you think through these systems, there's a lot of conversations back and forth, especially the use case that you brought up with wildfires. What sort of power sources that you're going to use, batteries or hydrogen or some of the other, hybrid solutions that are floating around. So as you guys sort of think through that for your use case, are you sort of open to all of those conversations, or is there one that sort of leads the pack in your mind as you start to build that, or is that still to be determined?
And is this when thinking about the wildfire use case, is that, yeah. So yeah. We're really agnostic. And in fact, we don't bring any preconceived notions about the nature of the solutions that can be employed in wildfires. We don't make any assumptions that eVTOLs are going to be involved in it. They might not. We are really stepping back and looking at this from a system-wide standpoint, taking a fresh look at the assumptions, at the first principles involved, and looking at this question from a forest management standpoint, from a remote sensing standpoint, from detection of a fire, the command and control and decision making that is in that loop from the time a fire is detected to the time that it is classified and then a response is decided upon, to then how the response is actually carried out. And also, if it becomes a long-term firefighting effort, then how can new technology better support the firefighters that are in the field? And so this is really acknowledging that technology has accelerated exponentially, obviously, in recent decades. And that in areas like fighting wildfires, we have people that are putting their lives on the line, and they deserve the best technology, and they deserve a pathway to bring these new capabilities that technology is providing, to bring it into the space and to find ways to operationalize it. And so there's a system-wide planning, there is a scanning for new technologies, there's an identification and filtering of new solutions, and then there's a selective investment of time and resources to further develop and integrate those into the operations. But what we're thinking, really about is in terms of not an assumption around any technology or any propulsion architecture, but really around, creating a link between people who have that rare operational and domain knowledge in the space with people who have, who are at the forefront of creating, foundational innovations in technology. Yes, a lot of our domain experience is around software touching the physical world, systems, aerial platforms, and we'll bring that knowledge and that type of insight to the discussion. But this is really, going to be based upon uniting, connecting those communities and creating a pathway for them to work with each other and for the innovation to find its way into the use case.
Awesome. Yeah, absolutely. And I think that's what we want to do across everything we do, right? Is really connect those, disparate parts and bring new solutions to, problems that we face. So we're out of time, but Peter, I think that was a perfect wrap up for us. Thanks everybody, PK, Dana, Peter, for your time. And I think we're going to hop over, at least you and I, Peter, to another panel. But appreciate it. Great conversation, and we'll talk later.
Okay, great. Thank you.